So when you open the start file, you can see this window. And firstly, you need to change the work plane to import the CAD file on the XY plane. Okay, so go to File and import DWZ and DWZ file and Excavation Advanced Course, the CAD file. Okay, so after import this CAD file, then you need to I will create the solid first for the ground. So using extrude function under here and select target and change the selection method to edge and turn on the intersect. Select here and Z direction and check on the reserve reverse line, reverse direction and give a 60. And this is the preview function. You can check whether your decision is correct. Okay, apply and go to top view again. And the next, I will make the solid for the retaining wall and excavation part. Same direction. Check on here. It's 12, means retaining wall length is 12. Okay, so when you hide, change to selection method to solid. And when you hide this one, you can see the inside solid here, what you created. And also you can check under here, the geometry tree. You can show and hide like this, or right click on your window and you can choose show and hide as well. And the next, I will copy this strut and value line to the proper layer. There are 2 layers of strut, means 2 layers of value. So using translate for the copying, but before that I will intersect this line first for the value for the meshing. Okay, so I will select those lines and intersect. Then you can see the lines are divided based on the point, the connection point. Okay, and then I will copy this strut to exact layer. So Z direction, copy 0.5 for the first layer and give the name S1, apply. And the second layer is 3, change name S2, apply. Then as you can see here, you can see the lines, they are struts for the first layer and second layer. Okay, and then I will copy the lines for the value and I will turn off this intersect function and select the lines for the value. Okay, and same depth 0.5 for W1. Okay, sorry, I will redo. Okay, select the lines for the value and choose Z direction, copy 0.5 for the W1, apply, and 3 for W2. Okay, I will hide curve for it. Okay, let me repeat again to copy the reinforcement. Okay, so select the lines for the strut, give a direction, copy, give the name, apply, S2, 3. Okay, and let me hide this one first. And I will copy the weller part as well. 2-point vector, Z direction, copy, minus 0.5. Okay, W1, apply, 3, W2. Okay. Okay. So when you show the everything is a reinforcement for the excavation, first layer and second layer. Okay. So the next I will using the imprint function for the solid with this weller lines for the generating the mesh. So activate the inside one, the solid, and go to front view. And the imprint function is here. Select, go to curve tab, and select the faces. Ctrl A is select all, and select the weller lines. I'm doing this one for the generating mesh, considering the weller lines. Okay. When you hide this one, you can see the line is staying there. So when you generate the mesh, the mesh will be created automatically and considering those lines, the imported lines, okay, imprinted lines. Okay, so the next, I will make the face to define the excavation level. Make the face and select edge, change, okay. And I will copy this face to the excavation level. -1, -3.5, -6. The values are inside the document what I will share the PDF and okay. And I will divide the solid based on the faces, those faces. And before that, when you change to selection method to solid, when you select this one, it's only one solid. But when you cut the solid based on the faces, then you can select the solid segment, which is divided by the faces. Just now I checked. Okay. And the next, I will make another face for the soil layer to cut the soil layer from the ground solid. So make the face, and I can tell you the face need to be bigger than the ground. It is better to cut. So I will change the faces scale using the scale function. And scale center, the center of the face, you can check the center of the face under here, the property window, and 60, 60, and 0. So 0. And you can choose a factor for the scale. And I will give the 1.2. There you can see the scale has changed. Ctrl Z and Y is undo and redo. Okay, and show every solid like this. And I will cut this solid using the faces. But before that, you need to copy these face for the solid layer. So direction is Z, copy. And first layer is until the 2 meter, apply. And 10 meter. Okay. So now using the divide the solid function, and select every solid and select the 2 faces. Okay. And let me show on the solid. Then you can see the solid has divided. Okay, so the next I will imprint the lines on the face for the surcharge area. So go to top view and imprint function using the imprint function and go to curve tab and select face on the ground surface and select the tool, the lines for the surcharge. It's 1 meter away from excavation area, and from here to here is around 10 meter. Okay, and select direction of shortest path. So when you change the selection method to face, you can select the face by face like this. Before that, you can select only one face under here. I will undo. See, you can select only one face, and after that, you can select the face by face based on your imprinted lines. Okay, so after that, while you created everything for the geometry, then you need to using the auto connect function to avoid the overlapping solids. So using this auto connect, select every solid, the 9 solids, and okay. Okay, so after you are using this function, when you hide inside the solid, as you can see here, the solids are avoided the overlapping part. Okay, so let me show you before I use this one. Okay, so when you select the solid and hide, nothing, because it is overlapping. After using this auto connect, when you hide this one, so you can see the overlap part has omitted like this. Okay, so the next I will give a size for the mesh. Okay, so I will hide every curve, only show this solid. Okay. The first I will give the size for the inside one is a smaller one. I select the edge is 2 meter of the size for the mesh. Apply. This one is 4 meter, and the outside 10 meter. Okay. Okay, so it is finished to before the generate mesh. So the next I will generate for the every solid. Control A to select everything. Right click, generate the mesh. And you don't need to give the size because I already defined the size for the mesh using the size control. And I am using the tetra mesh, and also you can choose a hybrid mesh. It's a square, it's a triangle. And property, I will keep the whether it's soil and apply. Oh no, just click OK. Okay, so now I'm finished to generate the mesh for the ground. And I will hide this one to avoid the confusing. Okay, you can hide and show the grid and axis system under here. Okay, so after that, I will hide every mesh for the ground, and I will show the solid and hide ground part. And now I'm creating the retaining wall using this extract function. Okay, select the face type, check off this intersect, and select the faces for the retaining wall like this. Okay, and check the property. There is only one, the wall, and give the name RW. Okay, when I hide this solid, you can see the created mesh for the retaining wall like this. And also under here, you can check the created mesh for the retaining wall. Okay, show and hide. And the next, I will do it again. Hide and only show here. And using again the extract function for the Weller. So select the edge for the Weller like this. It's already select the Weller. And W1 apply, and this one W2. Okay, so when you hide, see the Wellers edge generated like this. And I will create a mesh set for the strut and show the S1 geometry. And I will use 1D function to generate the strut and division given 1, and change the property to strut and S1. Apply. Sorry, need to select. Apply. And hide this one and show second strut and select all and give the name S2. Okay. Okay, so now I finished to generate the retaining wall and Weller's struts. I will hide this one and I will show the ground part. And as you remember, I assigned the properties only one, the whether it's soil maybe. So when you change to selection method to mesh set, and you can select the mesh set, and under here you can see the assigned property and materials. Maybe they are only one properties. So you can change the properties under the here, the parameters function. And go to 3D tab and change property and select the selection method to change to mesh set like this. select the mesh set for the first layer and turn on the intersect. Okay, so you can change the properties under here, this window. The first layer is bleed layer. Change to bleed layer and apply. And second layer also select with the mesh set. Second layer is column view. Okay, so after that, when you select this mesh set, you can see the property has changed like this. Okay, so and the next I will hide ground part and show the excavation part. And this one is the first excavation mesh set. So I will change the name using F2 or right click and rename EX1. And from here to here is a second excavation. So I will merge it first. Merge the select mesh set, yes. Okay, so select the mesh set for the second excavation and change the name EX2. And this is FVR, the last excavation mesh set. So select this one and you can see the highlighted under the mesh tree. Change the name FVR. Okay. So the next I will just show only retaining wall, and I will create the interface element on this retaining wall. So using this interface function and go to plane tab, from shell, select the from shell, the method type, and select all elements, the Control A, and merge node for the toe level, toe of the retaining wall, like this. Okay, and I will use a widget and give the reduction factor. I will just use a 0.67. Okay, and create the other element. Select rigid link. Okay. Then under here you can see the created interface and the rigid link here. Okay. So just now I finished to generate the mesh for the ground and structures. And I also considered the interface between the retaining wall and ground. So the next, you need to define the boundary conditions for the outbound of the ground solid. So go to auto using the constraint function under here. Okay, I will give the name BC. Then you can see the fixed like this. Okay, so the next, I will assign the self weight for the initial stress analysis. So self weight SW. Okay, then you can see this window, this arrow. And the next, I will apply the surcharge. So show the solid and go to top view and zoom in here. And using this one, the press function, the face and type, you need to change 3D element face, 25 maybe. And selection method to change to face, and just click here. Only here, and surcharge. Okay, and I hide solid. Okay, you can see the surcharge on the ground face. Okay, so Now I'm finished to define the load and boundary condition. And the next, the last one, I will define the water level for this 3D excavation. It is easier than other program. So just only show the solid here. And water level is here. Or here. It's the same. They are same. So click the water level and go to face tab. And interval just keep 1 and name initial. Just select the face. Okay. And you can see the created face under here, the analysis tab function and surface function initial. And also you can control the coordinate system, but it's a 3D, so mesh. So I will skip and water level again for the first excavation. So selection method change to solid and hide the first excavation solid. And click water level, face, and just select the face, EX1. Okay, and hide solid for the second excavation. I click water level, select the face, EX2, and hide the solid for the FEL stage. And water level again, face, select face. That's it, FEL. So now I finished today's session. What I did, such as create the geometry and generate the mesh and apply the load and boundary conditions, and also considering the interface function. And also just now I defined the water level.